All right, 5.6, we're going to talk about inverse functions today. So the term inverse functions doesn't refer to a new function, but it's a pair of functions, so two functions can be inverses of each other. And inverses just mean like the opposite. So we know that the inverse of multiplication is division. The inverse of addition is subtraction. So we're just going to be finding like the opposite function. So how we do that, we're just going to jump right into our first example. So to find the inverse, f of x we know is just a fancy way of saying y. It's the same thing as y. So to find the inverse, we switch x and y. So I'm going to change my y to be x, and then change x to be y. So everything else stays the same. I'm just flipping my x and y. So after we flip our x and y, we're going to solve the equation for y. So we need our equation to be y equals. So we have to move everything else to the other side. So in this equation, what would we move first? So our goal is to get it to be y equals. So we need to move everything else. I would have to move the 1 first. So I'm going to add 1 to move it to the other side. So I have x plus 1 is equal to 3y. And then divide by 3. So it cancels out there. So I get y is equal to x plus 1 over 3. Now the last step, we just have to name our inverse. So we put a little -1 exponent on the y just to say like this is the inverse of our function here. So this little symbol is just naming the inverse. Yeah, it'll always just be that little -1 on top. So it's just what you put there to say, this is the inverse. So it's not really an exponent, it's just like, here's our inverse. So this would be our answer. So let's take a look at number 4. So f of x we know is just a fancy way of saying y. What do I do to find the inverse? Switch x and y. So I have x is equal to 2y. Now we need to get y all by itself. So what would I have to move to make it y equals? 2. How would I move the 2? Divide by 2. Since it's being multiplied by the y, we do the opposite and divide. So now I have y is equal to x over 2. Am I done? I got to name the inverse. So I just have to put that little -1 on the y. And now we're done. Let's look at 5. So f of x is just a fancy way of saying y. What would I need to do to find the inverse? Switch x and y. So I'm going to change this to be x, and the x turns into a y. So x is equal to -y plus 1. All right, so now we need this to be y equals. So what would I have to do first? Subtract 1. So x minus 1 is equal to -y. Then what would I do? Divide everything by -1. Perfect. So when we divide everything by -1, we just flip the signs of everything. So it becomes a positive y, which was what our goal was. What does the x turn into? -x. And -1 divided by -1? Positive 1. And then what's the last step? Put the little -1 on our y just to name our inverse. All right, let's look at 6. So what should I do? I can change the f of x to be y, but then what do I do next? Switch the x and y. So make this x and make the x a y. So x is equal to 1/3 y minus 2. I got to add 2 first, to move it to the other side, because our goal is to get y all by itself. So x plus 2 is equal to 1/3 y. Awesome. I'm going to multiply both sides by 3 to cancel out with that 1/3. So it cancels with the 1/3. How would I multiply the left side by 3? What do I have to do? I got to distribute. I got to multiply both things by 3. So it's not the power of 3, it's just being multiplied by 3. So this would be 3x plus 6 is equal to y. What would I do next? Put the -1 on the y, just to name our inverse. All right, let's look at example 4. So it says, consider the function. We don't have to determine if the inverse is a function. We're just going to find the inverse, so just like we did in the last one. So how would I find the inverse? I can switch the x and the y. So I'm going to make f of x, x, and make x, y. So I'm flipping the x and the y. Switch the positions. So x is equal to 2y cubed plus 1. What would we do next? Do what? Before I divide by 2, I have to subtract 1. Sorry, I didn't hear you. So x minus 1 is equal to 2y to the 3rd power. What do I do next? Divide by 2. So x minus 1 over 2 is equal to y to the 3rd power. I take the cubed root of both sides. Awesome. So I cube root the left side to make it cancel out with the 3rd power. So I also have to cube root the right side, so I have to cube root the left side too. So since it canceled out with the y on the right, I have y is equal to the cubed root of x minus 1 over 2. What's the last step? Put that little -1 on the y, just to name our inverse. And that would be our answer. All right, example 5. So again, we don't have to determine whether the inverse is a function. We're just finding the inverse. No. What would I do first? Switch the x and y. So I'm going to make f of x, x, and make the x, y. So x is equal to 2 square root y minus 3. Now we're solving for y, so we need to get that y all by itself, so I have to undo everything first. What would I have to do first here? I have to divide by 2 to get that radical all by itself before I square it. So we have to divide by 2 first. So x over 2 is equal to the square root of y minus 3. Now we square both sides. So square both sides. So it cancels out here. You could leave it as x minus 2 squared. If we simplified it more, how would I simplify this? Perfect, x squared over 4, because the 2 would have to, the squared would be distributed to both of them. But it's fine if you just want to leave it like this, but put it in parentheses so we know that it's both the x that's squared and the 2 on the bottom that's squared. What would I do next? Add 3. So we have x over 2 squared plus 3 is equal to y. What's the last step? Put that little -1 to name our inverse. It doesn't matter if the y is on the right side or on the left. I usually put it on the left just to say like y equals this, but if it ends up on the right, that's fine too. It means the same thing. So you could have your answer written this way, or if you distributed the 2, like Lucas said, it would have been x squared over 4 plus 3. So either way would have worked, either answer. They're both fine, both right. All right, example 6 is a little bit different. It gives us 2 functions, and we have to verify if they are inverses or not. So how we verify is by taking one function and plugging it into the other, and then doing the same, taking that function and plugging it into the other one. So we have to do this twice. So I'm going to take my g of x here, take the entire function, and I'm plugging it into the x in my other function. So here I have 3 times x plus 1 over 3 minus 1. So I just take the whole function g of x and I'm plugging it into the x in the f of x. So we want to solve this, simplify this equation here. What would I do to simplify? So usually things will like cancel out because they're inverses. So if you're multiplying and dividing, adding and subtracting, they cancel. So what cancels here? The 3's. Because I'm multiplying by 3 and dividing by 3, so they'll cancel. So I have x plus 1 minus 1. Anything else cancels? The 1's. Plus 1 minus 1 would just be 0, so I'm left with x. And we have to do the same thing, but plug the other function into the other one. So I'm going to take f now and plug it into the x in the other equation. So 3x minus 1 plus 1 divided by 3. So again, we're just going to simplify it. We have to get the same thing in order for these to be inverses. So anything cancel out here? The 1's. You can't cancel out the 3's just yet because we still have those 1's in the way. So negative 1 plus 1 would just be 0. So now I have 3x divided by 3, which would be just x. So if these are equal to each other, then they are inverses. So we'd say yes, they're inverses. Or just yes is fine. So let's look at number 10. So we have to determine whether the functions are inverses of each other. So just like we did in the last one, we have to verify by taking one function and plugging it into the x in the other. So I'm taking this x plus 5, plugging it into the x. So it'd be x plus 5 minus 5. Anything cancel here? The 5's. So what am I left with? X. Now we have to do the same thing, but we're going to take g and plug it into the x in the other function. So x minus 5 plus 5. Anything cancel here? The 5's. So what am I left with? The x. So are these inverses of each other? Yes. Last one, let's look at 11. So how do I verify that these are inverses? What do I need to do? Plug it in. So I'm going to take f and I'll plug it into the x in g. So the cubed root of 2 times 8x to the third power. What would I do first? I would multiply 2 times 8. So this would be the cubed root of 16x to the third power. We can simplify this a little bit. What are factors of 16? 4. And factors of 4? 2 and 2. I circle groups of what here? Groups of 3. So a group of 3 2's. So what comes to the outside? A 2. What stays on the inside? A 2. Let's do the same thing with the x's. How many x's do I have here? 3 x's, and I circle groups of what?
3.
Groups of 3, so what comes to the outside? 1 x. So this is as simplified as we can get here. What do I have to do next? Do it the other way. So I'm going to take g and plug it into the x there. So I have 8 times the cubed root of 2x cubed. Anything cancel here? The cubed root and the cubed will cancel. So then I have 8 times 2x. What would I do next? I can just multiply 8 times 2, which would be, so 16x. So this is as simplified as I can get here. Are these two inverses of each other? No, because these are not the same. They're not equal, so they are not inverses. It's not always going to be like x is equal to x, but usually that'll end up being the case because everything undoes itself.